And welcome back to another video, another math tutorial. In today's video, we are going to discuss simplifying radicals, simplifying square roots, and simplifying cube roots. So let's go ahead and get started. The number one strategy we are going to use today when we simplify roots is going to be prime factorization. I am going to pin a separate video here as well in case you need more of a review on what prime factorization is, but that's going to be our method for solving or simplifying the roots today. So let's get started with the first example. We have the square root of 180. I do know this is a square root because there's no number out here, no index. And so that invisible number is the 2. It is an invisible square root. So no number means a square root. And we have 180. To start with, guys, you always want to see, first of all, if it's a perfect square, because if it is, then we don't have to kind of go through all of this trouble if you kind of memorize your perfect squares. So we know 10 squared is 100, 11 squared is 121, and then you could keep going, 12 squared is 144. Is there a number that we can square to get 180? And the answer is no, right? So it's because 13 squared is 169, and then 14 squared is 196. So we skipped over 180. It's not a perfect square. So that means we are going to need to use this process in today's video, prime factorization, in order to simplify this root. Okay, I do have another video where we simplified it using perfect squares, but today's method technique is going to be using prime factorization. So over here to the side, we're going to want to break down the 180 into its most simplified, its prime factors, right? Factors, numbers that multiply to be 180, but numbers that are prime, meaning they can only be formed by multiplying 1 and itself. Okay, so I'll show you what I mean by that. So to start off, let's just kind of think of two numbers off the top of our head that multiplies to be 180. And right off the bat, I think of 10 and 18. You might have thought of something else, and that's okay. 10 and 18 just kind of immediately came to my mind. Now, 10 and 18 are not prime. We can keep going. So let's go ahead with the 10 and break it down. 10 can be formed by 2 and 5. Okay, now the question is, can we go further? Can you split 2 into something other than 1 and 2? No, you can't, and that's why this is prime, okay? Just 1 and 2, so we can circle it to identify this is a prime factor. Same thing for 5. 5, you cannot break down any further, just 1 times 5, so 5 is also a prime factor, and we circle it to distinguish. Okay, so this part of my prime factor tree is complete. Let's move on to the 18 and break it down. So 18 can be broken down into 3 and 6, or you could have said 9 and 2. There's a number of options, but I thought of 3 and 6. 3, of course, is prime, so we can stop right there, so we leave it. However, 6 we can break down further into 2 and 3. And I know I went through that really quick, but like I said, I'm going to pin the video on prime factorization so you can see that process all explained. Okay, so all the numbers that are circled are the prime factors of 180. So let's come over here and rewrite this example question, not with 180, but with all of these prime factors. And I suggest just kind of as good housekeeping to write the numbers together. So like in from least to greatest or however, but just keep the numbers together. So 2 and 2, put those together, times 3, times the other 3, we're putting those together, and then times 5. Okay, so we're just replacing it because they're equal. Mathematically, 180 and 2 times 2 times 3 times 3 times 5 are equal to the same thing, so I can replace that. So that's what we did, okay? Once you have the prime factors, now we can talk about simplifying the root and taking things out from under the radical, right? Out from under this box. So since this is a square root and square root is 2, right? Anytime we have a pair of a number or a variable or whatever, we can circle it and it can come out of the radical. So we can circle 2 and 2 because there's 2 of them, that's a pair. And same thing for 3, there's 2, so we can circle it. The 5, however, there's only 1. It doesn't have a pair, so it doesn't get to be circled and come out, okay? So let's take the 2 to the outside of the radical. And you might ask, how many 2's can I take out? Well, you take out however many circles you have, and I only have 1 circle of 2's, so just the 2. I can also take out a 3, right? How many? Just 1, because there's only 1 circle. All right, so I got rid of the 2's, got rid of the 3's, and then the 5 is left inside, okay? And then we just want to simplify this as much as possible. So 2 times 3, right, is 6, and then square root of 5. That is our solution. We have simplified the radical, square root of 180, using prime factorization. Let's do another example. Example 2 has the square root of 20x to the 8th. So notice this time I have variables involved. So we're simplifying a square root with variables, all right? Or simplifying radical expressions. We want to go through the same process. We're going to use prime factorization to break down this 20 is the first thing we'll do. So think of 2 numbers that multiply to give you 20, could be whatever. I think 4 times 5, right? We know 5 is a prime number, so we're able to stop right there. However, 4 is not prime, so we need to keep going, break it down some more. So what's 2 numbers that multiply to be 4? Would be 2 and 2, and those are prime. So once again, we will replace the number inside with the prime factors. So no more 20, we're going to rewrite it as 2, 2, 5. Now this time we have a variable. We have an x, and we actually have x to the 8th power, which means we have 8 x's. And I strongly encourage you to expand them, write each x out. So we want to write 8 x's. All right, so now that we have everything expanded, we've got 20 expanded in prime factorization, and we have x to the 8th in expanded form. Now it is time to go through and circle our pairs. And once again, it's a pair because it's a square root. I know it's a square root because of the invisible 2 right here, okay? So there's 2 2's, I can circle that. Oh, just 1 5. But I have a lot of x's, I can circle pairs of those 2. So I'm going to circle, there's 1, 2, 3, 4 pairs of x's, okay? Now we're ready to take those things that are circled outside of the radical. So I have a 2, definitely can come out, but there's only 1 circle, so it's just 1, 2 that comes out, okay? And I have an x that comes out, right? How many x's? Look, there's 1, 2, 3, 4 circles. So I have 4 x's, and I'm going to shorthand that with an exponent. Okay? And that takes care of everything that gets to come out. And what's left inside? The 5. So that's how we would simplify this square root using prime factorization. And our answer is 2x to the 4th, radical 5. Okay, we're going to move on to cube roots now. How do we simplify cube roots using prime factorization? So we have example 3, the cubed root of 27. And I know this is a cubed root because this little 3 out here that kind of looks like an exponent, but since it's on a root, is called an index. So this is the index of our radical here. And I'm going to go through the exact same process. First thing I want to do is break down 27 into prime factors. So just think of two numbers right now that multiply to give you 27. And I think 3 and 9 off the bat. And we know 3 is prime, but 9 isn't. So we have to keep going. What's two numbers that multiply to be 9? Would be 3 and 3. So we're ready to rewrite our number under the radical. Keep your index. And instead of 27, we're going to write 3 times 3 times 3. So far, the process has not changed. We do the exact same thing. Take your number under the radical, the radicand, is what it's called. Take that number and expand it using prime factorization. So we did that, and then we replace it. So nothing's changed. At this point is where we have the difference. So before we were circling pairs because it was a square root. Since this is a cube root, meaning 3, we're going to circle 3 of an item. Every time we have 3 of an item, we can circle it. So 1, 2, 3, I can circle. Okay. And remember, if it's circled, it can come out. So a 3 can come out. How many 3s? 1, because there's only one circle. But when I do that, there's nothing left inside. So my radical just disappeared because there's nothing left. I mean, you could waste your time by putting 3 and then the cube root of 1, but complete waste of time. Not highly skilled to have that there when it simplifies just to 3. So our answer is just 3, which means 27 is a perfect cube. Perfect cube because you got 3. You multiply the same number times itself 3 times. Okay, so perfect cubed of 27, that's why we don't have anything left over. But the process was the same. You saw prime factorization and then circle 3 numbers because it's cube root and then pull it out. Okay, let's see another example. So for our last example, we have the cube root of 32x to the 7th. So just like we've been doing, we want to break 32 down into prime factors. So let's start with 8 and 4. I know 8 is not prime, so we can break that down even more to 2 and 4, right? But 2 is prime, we can stop there. 4, we can break down into 2 and 2. Okay, so go back to this 4, break it down, 2 and 2. Okay, so I have 1, 2, 3, 4 5s. That makes 32. So let's rewrite our radicand over here. So now we're taking the cube root of 2 times 2 times 2 times 2 times 2. And when we have x to the 7th, we know that that's just 7 x's. Let's go ahead and write that down. So once you have everything expanded, all we're doing now is circling trios, circling when we have 3 numbers. So 1, 2, 3, circle. Oh, there's 2. Not enough for me to circle, not for a cube root. I have 3 x's here and then 3 x's here. And that's all I can circle. Now we're ready to pull things out of the radical. We can take a 2 out. How many? Just 1, because there's just 1 circle. We can take an x out. How many x's? 1, 2, because there are 2 circles. So I can do that with the exponent. Okay. And then we just leave the radical with whatever's left inside. So we got a cube root of 2 times 2 and an x. So we don't want to leave it as 2 times 2. You want to put that as a number. So 2 times 2 is 4. And then bringing down this x right here. Okay. And that is how you would simplify square roots and cube roots using the process of prime factorization. Okay. Hope this was helpful, guys. I will see you in the next video.